Hello everybody, this is part 3 of the Surds topic. Our heading for part 3 is addition and subtraction of surds. So last lesson we looked at what a surd is, and then we looked at some of the rules surrounding surds with multiplication, division, powers, and then simplifying our surds. Today we're looking at addition and subtraction. So to start with, rather than some notes, we're just going to start with a little example. The square root of 4 plus the square root of 9. Okay, so have a little look at that. If we wanted to simplify that or combine them, what might we do? Well, it might be common or to think that, well, when we times, we put it all under 1. So let's do the same here. And what is 4 plus 9? That's 13. So is the answer the square root of 13? Well, let's have a little think. What is the square root of 4? That's 2. What is the square root of 9? That's 3. So really, our answer should be 5. Okay, that's correct, which means that's wrong. Right, so what we can see from something like this is that if we have the square root of x plus the square root of y, where x and y are different numbers, okay, this is not equal to the square root of x plus y. And the same for subtraction. Okay, we can't just combine them. These are rules that we can see by an example such as that. They just don't work. So only like surds. Only like surds. Actually, let's put that in bold. Okay, just like when we think about adding and subtracting like terms with algebra, okay, only like surds can be added or subtracted. And I find that's a good way to think about it. We're used to those rules in algebra by now, I would hope. And so we can kind of think of, if we replace a surd with a pronumeral, it might make a bit more sense. So let's say we had an example, 2 root 3 plus 4 root 3. Well, if we thought instead that this is like 2 lots of A plus 4 lots of A, we would say, okay, A, like terms, so I can add them together. 2 lots of A plus 4 lots of A is 6 lots of A. So with our surds, if we've got 2 lots of root 3 plus 4 lots of root 3, that's 6 lots of root 3, so we can add those. Okay, that's good. But if we had something like 2a plus 4b and said, oh, that's like 6ab, well, we know that's wrong, don't we? That's wrong, but these two are good. So what's another example? Let's say we had 5 root 2 minus 4 root 2. Okay, we would look at both of those. We go, well, they're both root 2. Okay, that's square root of 2, that's the square root of 2, so they're like surds. So we can subtract them. 5 lots of root 2 minus 4 lots of root 2 just leaves us with 1 lot of root 2, or root 2. Okay, so that's good. Alright. Now, sometimes though, it's hard to tell if we have like surds or not. The only way we can tell for sure is if we simplify first. Now, we talked about simplifying last lesson, so we're going to have to use some of those skills now. So we can only tell if surds are like if each is fully simplified. So that's it in terms of the notes. We're just going to do some examples now to finish off. We'll do 5 examples. Okay, so we've got a few, but they're all show certain things. Alright, first example. 4 lots of root 3 plus 7 lots of root 3 minus 2 lots of root 3. So, do we have like surds? We sure do. Root 3, root 3, root 3. So, we can just ask ourselves, what's 4 plus 7 minus 2? Okay, 4 plus 7 is 11, take away 2 is 9, so we have 9 lots of root 3. Alright, pretty straightforward. Let's have a look at the second example. 8 lots of root 2 plus root 5, so that's 1 lot of root 5, minus root 2, so 1 lot of root 2, plus 2 lots of root 5. Okay, so here we do have some like terms, or some like surds, I should say, but not all of them are like surds. So there's a root 2 and there's a root 2, so we can combine those. So 8 lots of root 2 minus 1 lot of root 2, that's 7 lots of root 2. And then we can look at the root 5s. There's one, there's another, so let's combine those. 1 lot of root 5 plus 2 lots of root 5 is 3 lots of root 5. Oh, sorry. 3 lots of root 5, not 3. And that's it. We can't do anything else with that because root 2 and root 5 are not like surds. So that's our answer. Alright, example 3. The square root of 8 plus the square root of 18. Now I'm going to write these in different colours. Okay. Square root of 8 plus the square root of 18. Okay, what does that equal? Now, like we just wrote above, okay, which I'll highlight now, we can only tell if surds are like if each is fully simplified. Now, are either of these surds simplified? No, they're not. They're not fully simplified. So that's what we need to do first. So, refreshing from last lesson, let's look at the square root of 8. Okay, square root of 8 can be broken up into the square root of 4 times the square root of 2. Remember, we're looking to see if there's a square number that goes into 8. And the square number that goes into 8 is 4. Okay, and square root of 4, well, that's just 2. Well, square root of 4 is just 2, so this is 2 times root 2. Okay, and that's fully simplified now. But we've also got this root 18. What square number goes into root 18? Well, that would be the square root of 9. Okay, 9 is our square number, and 9 2s are 18. So that's how we're going to simplify this. Square root of 9 is 3, and root 2 stays as root 2. And now we can see that we've got like surds. They're both root 2. So we can finish off our answer by saying, well, 2 plus 3 is 5. So we have 5 lots of root 2. Okay, so on first inspection, the square root of 8 and the square root of 18 were not like surds. But when we simplified, we saw that they were actually like surds. So we could go and add them together. Alright, fourth example. 2 root 12 plus 3 root 48. Whoa. Plus 3 root 48. Alright. So let's, once again, we're just going to focus on the blue, so on the 2 root 12. Okay, that's 2 times root 12. Okay, so I'll put the 2 there, but now let's just focus on the root 12. How can we simplify that? Well, 4 is a factor of 12, and 4 is a square number. And how many times does 4 go into 12? 3. So now we have 2 times 2, because the square root of 4 is 2, times the square root of 3, which can't be simplified. So that's 4 root 3. Okay, now the green part. 3 root 48. 3 times... Okay, what square number goes into 48? Now 4 is a factor of 48. Okay, so it could be 4, but there is actually a higher one than that. Now 16. 16 goes into 48 3 times. If you say you thought it was 4, that's okay if you thought it was 4. You'll just find that you can simplify even further a bit later on. So always try to get the highest square number where possible. Alright, square root of 16 is 4, square root of 3 we can't simplify, and 3 times 4 is 12. So 3 root 48 simplifies down to 12 root 3. And now we have like surds, so we can combine these. 4 plus 12 is 16, lots of root 3. Alright, doing well. Last example. Okay, save the hardest for last. Alright, once again, we'll do it in 2 separate colours. No, we might even use 3 colours for this one, because this one has 3 terms. So 2 root 75 minus the square root of 45 plus 2 root 20. Alright, so let's just focus on the blue, one bit at a time. Okay, 2 root 75. The highest square number that goes into 75 is 25, and 25 goes in 3 times. The square root of 25 is 5, and so this part simplifies down to 10 root 3. Let's look at the square root of 45. What is the highest square number that goes into 45? That's 9, and it goes in 5 times. The square root of 9 is 3. So what we have is negative 3 root 5. Sorry, a little bit slow there. And finally, 2 root 20. Let's put that 2 out the front. What square number goes into 20? That's 4. It goes in 5 times. The square root of 4 is 2. And 2 times 2 is 4. So there's each of those fully simplified. And now we can have a look at which ones are like surds. Okay, the 10 root 3 is the only root 3 term, but we do have a negative 3 root 5 plus 4 lots of root 5, so that's just 1 lot of root 5. And that is our fully simplified answer. Everything added and subtracted where possible. So just reviewing. Okay, we can't just add different surds. Okay, that's incorrect. The square root of x plus the square root of y does not equal the square root of x plus y. Only like surds can be added or subtracted. Get rid of that there. Okay, we looked at some examples, and remember we can only tell if surds are like if each is fully simplified. And then we had a look at 5 different examples. Alrighty, that's our lesson on addition and subtraction. Thank you very much.